User Datagram Protocol, also known as UDP, and the Real-Time Transport Protocol, known as RTP. I'm also going to go over remote procedure calls and the Real-Time Transport Protocol's little sister, Real-Time Transport Control Protocol. So first, let's look at the User Datagram Protocol. All right, so there's two types of protocols in the transport layer, and that's what we're covering is the transport layer. You have connectionless, and then you have connection-oriented. UDP is connectionless, while TCP is connection-oriented. So there's certain applications where you want to have a direct connection with the computer that you're transmitting data to, and there's some applications where you just want to send your packets out, in random bursts, and it doesn't matter what order they come in or anything like that. So this runs over IP, so it uses IP datagrams to send data, and it's generally known to be unreliable. So TCP is the more reliable counterpart to UDP, and that's partially because UDP allows packets to be lost. It uses checksum for determining data loss, and I'm just going to go over kind of how the checksum works. A little demonstration for you guys. So okay, so let's say you got data that's been split down into 1, 0, 1, 1, 0, 1, 1, 0, 1. And you're adding that to 0, 0, 0, 1, 1, 1. Sorry, my handwriting's terrible. So what it first does is it adds up all the data, basically. And if you added all these up, you would get, 1, 1, 0, 0, 1. Okay, so this is the sum of all of your data. Say you're transmitting a text file or something, and it adds up all the words together, you get that. Now it takes the ones complement of that, and then it adds, so a ones complement is basically you just reverse all the numbers. So if you have a 1, you do a 0, if you have a 0, you do a 1. Then it adds these two numbers together, and if no data has been lost, none of the packets have been lost, then you come out with just 1, 1, 1, 1, 1, dot, dot, dot. So it's not necessary for you to have a checksum in IP version 4, but in IP version 6, it is necessary to have a checksum. So you don't, there's no option, you have to use it. That pretty much sums up checksum. So yeah, obviously if you if you wanted to send no data, the reason that they use ones complement is because if you just sent no data at 0, it would mistake the no data for data. So it does a ones complement, and that lets you set it to 0 if you don't want to send any data. Okay, so UDP works by giving apps access to the datagram service of the IP layer. User applications must handle problems with end-to-end communication, such as network congestion, assembling, reassembling packets, and retransmission of lost data. So if you want to handle any of that, you have to build it into your application, while TCP handles all that on its own. Okay, so here's an example of how the not only how the packets are nested, but also an example of a UDP header. you'll see that, excuse me, the source port's 16-bit, destination port's 16-bit, length 16-bit, checksum 16-bit, and then the data, 32 bits. The source port and the destination ports indicate what application sends the data and which should receive it. So here's a comparison of TCP and UDP. TCP is known to be reliable, while UDP is not. TCP is ordered, UDP is not. Now one of the reasons why UDP is so useful in some applications is it's lightweight, it's light overhead, and statogram oriented. So Steve Jobs wants to know, why would you want to use UDP? The main advantage of using UDP over raw IP is the addition of source and destination ports. So you can send your data to specific applications. There's no congestion control, end-to-end connection, and light overhead results in faster speed. This is used in applications such as online games, streaming media, domain naming system, routing information protocol, and the dynamic host configuration protocol. So now we're going to go on to the remote procedure call, which is a high-level protocol that, oh, I skipped my video. Oh no, it's at the end.
Don't worry,
It's remote video. Okay. So it's a high-level protocol that allows procedure calls to be made on remote host. An example procedure call would be get IP address and then the host name. Basically, it allows you to, when you're building your application, to use a procedure call as if it were a local call, when really you're getting data from another computer. And it's used for creating client-server-based applications. Xerox was the first company to use it, and it was in 1981, and it was called Courier at the time. It's important for distributed applications. And RPC typically uses UDP for sending data, but may use TCP if the data cannot fit in a datagram. Okay, so an example of an RPC, how it would work. The client invokes the client stub procedure, passes the parameters. The parameters are packed into a message, which they call marshalling. The message is then passed to the transport layer, which transfers it to the remote server. The server stub takes the message, they demarshal the parameters, and calls the server routine. The server stub marshals the return value and sends the message back to the client. And the message is then demarshalled by the client stub and returns the parameters given to the application executing the call. So now we're going on to the real-time transport protocol. It's used for sending audio and video data over IP. Applications such as Skype, Google Hangouts, Ventrilo. It's primarily voice over IP. It multiplexes multiple data streams onto a single stream of UDP packets. It can be unicast or multicast, and it has the ability to timestamp. And it typically is used in conjunction with UDP for its checksum and multiplexing attributes. Okay, so this kind of shows you how the packets are nested. So you have your Ethernet packet, which carries everything. You have your IP packet, which the UDP packet is inside the IP packet, and the RTP packet is inside the UDP packet. And if you'll notice, you access UDP and IP through your OS kernel. So it's built into the operating system, while RTP is just a protocol that's used for invoking a procedure on another computer. So it's not built into the operating system. RTP has a sister protocol. It's called Real-Time Transport Control Protocol. Does not send any data. It merely works in conjunction with RTP for the delivery of audio and video. It provides feedback on the quality of data being delivered, such as packet counts, round trip delay, and packet loss. So whenever you're sending data, it'd be nice to have kind of feedback on how that data has been transmitted, and you guys are talking about quality of service, and your presentation. So, that's a very important attribute for it to have to determine the quality of service. Okay, so now we're going to go for some questions. See if maybe any of you guys will answer. We don't have anything to bribe you with. I don't got pizza or anything, so hope you answer.
Get a big old thumbs up. Though,
yeah, you get like a hug or something. So which delivers data faster, UDP or TCP?
UDP.
Correct.
Okay, which transport protocol does RTP usually use for sending data?
UDP. Bad.
Got it. Can RTP be used to send multimedia data to multiple computers, or can it only send data to one computer? That's right. There's multicast, not unicast, and that's one of the reasons they use it. Okay, so Google's been they've been developing a new transport protocol called QUIC. They've actually they work on TCP2, but I don't think QUIC will ever actually be like widely used. But you can use it with Chromium to kind of experiment with it or whatever. The guy in this video he's British. He's kind of monotone, but he gives kind of a rundown on how UDP and TCP works, and also what QUIC is and all that. So we're just going to take a glimpse of that.